All right, welcome to AP Calculus. We are on lesson 1-4 today. Today's date is Friday, August 28th, 2020. Our objective today, who am I going to call on? Yeah, Chris. Oh, I don't have an objective? What? Oh, man, that's a mistake. Well, I'll say the objective and write it down for next time. Our objective is to determine types of discontinuities, and that's the first part. Let me look at the second page. What are we doing here? We're also proving continuity and prove continuity. If I had more room, I would say prove continuity using the continuity test, but I think that's kind of self-explanatory. The continuity test does not prove anything else aside from being continuous. So we should talk about what it means to be continuous. I kind of alluded to what this was in 1-3. In 1-4, now we're actually proving it. A graph is continuous if you can trace the curve with a pencil. That means if you press down on your pencil right now and trace that V or trace whatever, it means you can trace the pencil without doing what? What would be your guess? I think I said this yesterday too, if you can remember back. Quiet raised hand, without doing what? Fiona?
Without picking it up.
Exactly, without picking it up. I guess I'll say lifting the pencil up. Exactly. That's a very simple way that I wish college had taught me, because in my calculus class, we didn't actually formally go over what it meant to be continuous. And then until I got to college, they had this very weird definition that you're gonna see down here. They're like, this is what it means to be continuous. And you're like, okay, I'll just memorize that definition. But it's really just like, can you not pick up your pencil? That's really the definition of being continuous. So go ahead and try these out. Do you think that this blue V is continuous? Everyone give me a thumbs up or thumbs down, either in their camera or the interface. Thumbs up, thumbs up, thumbs up. And okay, yeah, it's continuous, light, because I can hold down my pencil. I've never lifted up. There's no problems there. So go ahead and say, yeah, that one's continuous. And I'm just gonna say continuous and abbreviate cunt, and then not say like the rest, not continuous. Then the other one, it could be discontinuous if it's not continuous. All right, so orange one, thumbs up, thumbs down. Is it continuous, discontinuous? Discontinuous is thumbs down, continuous thumbs up. Yep, everyone is giving me the thumbs down. It is indeed discontinuous. I'm gonna abbreviate there. What about this red? I think it's red. I don't know what color this is. Brown, whatever this is. Is this continuous, discontinuous? Thumbs up, thumbs down. I'm getting all the thumbs up and you're getting it correct. It is indeed continuous. What about this one on the far right? Continuous or discontinuous? We have one thumbs down, two thumbs down, three thumbs down, and Chris also gives the thumbs down. It is indeed discontinuous. Now why? Why is it discontinuous? Well, I had to pick my pencil up. Okay, well, that's the kindergarten version of continuity. And there have been cool studies that show you could teach calculus to kindergartners if you phrase it in the right way like this. Let's be a little bit more formal. We're in high school, we're seniors. How do we do this? So there are, generally speaking, 4 types. One of them is kind of hit or miss. Khan Academy will only have 3 types. So these are all the 4 graphs that I have. I'll go ahead and let you copy these down really quick. Again, it does not matter that you have these exactly, just the general shape. This should take you 30 seconds. Like, what would be, that's 7.5 seconds per graph. Just whoop, and then draw a little open hole there. Go nice and quick. Okay, so first type. This is called a hole, or what I call a hole. Khan Academy calls this just removable. So hole/removable discontinuity. And look, there's a hole there. I mean, you could have also put a point, like if I put a point up here at, I don't know, just anywhere that was where this hole should have been, that's still a hole or a removable discontinuity. if there is a point, if there isn't a point, still the same thing. This I call a gap, but Khan Academy calls it something else, so you'll get familiar with both names. So I call it a gap. Khan Academy calls this a jump. A jump discontinuity, or there's a gap in the graph. This one is not on Khan Academy in the bottom left, and it is technically not continuous at that point, just because it doesn't satisfy the definition of being continuous, because, and it's very pedantic, it's very formal to say it's not continuous, but I'm going to call this an end. There's an end to it. If at that exact point, it is not continuous. So a lot of the times when I'm doing the interval, they'll say on the interval, not including 0, that way it's not at the end, from 0 to whatever, it's continuous. Yeah, that's great. But if I did something like this, 0 to infinity, okay, it's not continuous at 0. So now this piece breaks continuity because I am including an endpoint. Typically, you try to get rid of that endpoint by saying don't include that endpoint. Not super important, but ends are discontinuous. And then finally, this is called vertical asymptotes. Vertical, I'm just gonna say VA, vertical asymptotes. And I think, I can't remember how Khan Academy, I think they might say like an infinite or it does not exist or something like that. A vertical asymptote or diverges to infinity. I can't remember how Khan Academy says it. I'll say diverge to infinity. I think they might say that like that. But I want to go ahead and take a look at the limits, drawing from our information from the last few days. What's happening with our limits here? So really quickly underneath this graph, I want to figure out what's going on with the limit as x approaches, in this case, this is going to be my -2, that vertical asymptote, -2, I don't know, just randomly from the left. From the left, that means I'm going closer and closer to what height? What would you guys say here? As I get closer and closer to this vertical asymptote from the left, from this direction, what height do I approach? With a quiet raised hand. What height am I getting closer and closer and closer to the closer I get to -2, the x coordinate -2? The y coordinate gets closer and closer to Teflon?
7?
Well, it goes off the graph. If I had an infinite graph, it would go up towards where?
Positive infinity.
Positive infinity, yeah. And to be formal about it, we say it does not exist. So this limit of, I'm going to call it f of x, I guess. The limit of this function does not exist. Or if you're being, sometimes you can say like it goes to positive infinity. You're kind of correct, but being formal about it, it does not exist. And I want to talk also what it means to be defined or undefined, because it'll help us in our homework and just in general calculus knowledge. So if there was a point here in our first graph, if I drew a point here, I could say f of -2, what is the height of -2? I could say is defined if there was a point, right? So if there was a point. So there's a point here, so it is defined. There is some sort of height. It's saying, hey, is there a height when I plug in -2 for the x coordinate? And I'm saying yes. But if I were to get rid of both those points that I drew, and I only had this open point, then it's not defined because there's no height there. When I plug in -2, it doesn't know where to go. There's no y coordinate that corresponds to the x coordinate -2. So that's the difference between defined versus undefined. Defined has a height, has some sort of point to go to. Even if it's weirdly not continuous, it still is defined. Whereas if there isn't a point, then it's not defined. There's no corresponding y value. Same thing for like over here. So if I asked you, what is f of 2? Would you guys say defined or undefined? Give me defined is thumbs up, undefined is thumbs down. So everyone participates. F of 2 for this graph over here. Is f of 2 defined or undefined?
Well, I don't know.
I don't know, in the middle, I guess. So this one is undefined. Why? This is undefined because if I were to draw a wall at the x coordinate 2, the wall would be right here, and it doesn't go through any point. It doesn't touch the graph. These are open points, meaning it doesn't exist there. This is another open point. Nothing exists at this point, so this is undefined. Over here, if I drew the wall, if it crosses through a point, okay, it's defined at that point. Oh, it would be defined at that point, but it's not defined at that point. To be defined means it has a y coordinate. It touches the graph somewhere. All right. And I'll talk about that again in a sec. But let's move on to some more notes. I'll let you guys copy this down.
Can no one else hear Mr. Sindel?
I can't hear
What?
him.
I talked that whole time and no one said anything? Why, guys? Okay.
Were you muted or something or what?
When I leave this piece up, but if I bring it down, then you can hear me.
Oh.
Ah,
I was waiting.
Okay.
I was like, what the heck is Musician Dog doing, man?
why? Thank you, Teflon. I wish that someone would have said something earlier. But anyway, this is the left piece. This is the right piece. This is the actual height. So, yes, you need to make sure that all of these things are equal to each other. These are all the y coordinates, by the way. So the y coordinate as I approach C from the left, this is the y coordinate as I approach C from the right, and this is the actual y coordinate at that value of C. You're verifying kind of the y coordinates, what you approach from the left, what you approach from the right, what you actually have at that height. Before, remember how I said, oh, I don't care? Well, you don't care for the limit, but you do care when it says f of C. What is that actual height? All right, so let's go ahead and try these things. Again, remember that this 2, we call that the suspect point. I'll go ahead and label it again, suspect point. All right, so as I get closer and closer to that suspect point, from the left to the right, the actual height, I'm using this definition right now, and I'm gonna see if this is continuous. So I'm going to rewrite this definition. Go ahead and rewrite it with me. The limit as x approaches, it's not C anymore. Our C is our suspect point. This is the thing I'm getting closer and closer to. 2 is the thing I'm getting closer and closer to. So x approaches 2 from the left for our function f of x. So limit of f of x as x approaches 2 from the left should be equal to the limit of, I guess it's h of x, isn't it? It's not f of x. Let me undo that. Sorry about that. Can I just grab just the f? There you go. It should be h of x. Should be equal to the limit of h of x as x approaches 2 from the right. And that should be equal to f of 2. Again, all of the c's are replaced with 2, the suspect point. So I can make a note over here. C is the suspect point. And you can kind of understand why I'm calling it the suspect point now. We suspect that at that point we are continuous, but we don't know, so we need to use this continuity test to verify that. Okay, so how do I do this? And this is coming from the homework from yesterday. Hopefully you remember how to do this. If I have a piecewise function and I'm trying to plug in 2 from the left, am I plugging into x plus 2 or am I plugging into x squared with a quiet raised hand? Which piece am I plugging this into, this suspect point 2? Don't know who that is, I'll hang up on them. Come on, guys. Yeah, Teflon again.
The top one?
Top one, yeah, why?
Because I remember you saying that the top was the left and then the bottom was the right.
Exactly, yeah. The top is left, the bottom is the right. And why? Because this is left of 2. X is less than or equal to 2. That literally means left if you assume right is positive, which we almost always do. And X is greater than 2. That's everything greater than 2 is on the right of 2. So this left piece is going to be talking about this equation right here. And we're going to plug our suspect point 2 into our X, and nice and easy. You guys can all shout out or hold up number of fingers. What do we got here? When I plug in 2 into our left piece, what number do I get out? Fiona has it, Teflon has it, Chris has it, Andrea has it. Okay, 4. So 4 is that height. Now I'm going to plug in to the right piece. As I approach 2 from the right, it's talking about this piece of our piecewise function. And hold up again. When we plug in our suspect point, what height do we get? Fiona has it, Andrea has it, Chris has it, Teflon. When I plug in 2 into X, 2 squared, there it is, 4. So this is equal to 4. Okay, so far so good. We haven't met the third criteria also. Now we need to actually plug into the actual height. Well, what do we do here? What do we do for f of 2? How can we use our piecewise function to find what f of 2 is? Any ideas? So remember, this is the actual height. This is when I actually am at 2. So which one is equal to 2? Is this one equal to 2? Is that one equal to 2? Which one is equal to 2? Is it the left piece or is it the right piece? Is it the first equation? Is it the second equation? Which one is equal to 2? And I'm seeing a lot of blank faces. This one is equal to 2 because it says less than or equal to 2. Because it has this bottom little bar, I'm going to be plugging into this piece right here, which is kind of silly because we've already plugged into it, but there it is. The left piece says it's equal to 4. And hey, lo and behold, all 4 of these y coordinates, or all 4 of these pieces, are the same, and therefore it is continuous at our suspect point, x equals 2. So we want to say down here, h of x is continuous at x equals 2. Why? Because it passes the continuity test. All right, you guys want to try a harder one? Well, maybe you guys should give me a fist of 5. How do you feel about example 1? If you saw something similar to this, how well could you do it? How well could you use the continuity test to prove if it's continuous or discontinuous? I'm seeing 4, 4, 4, 3. Okay, so we'll get some more practice with this. But the main thing is just write out the definition, find out what those are, and then plug them in. If even one of them is not the same, then it's not continuous. All right, so example 2. Now we're going to go ahead and say, let's try to make this thing continuous. We're going to find a value of k that will make this thing continuous. And it looks like you guys are all going to be writing down for a little bit, so I'll give you time to write this down. Here you go. Okay, so again, we're trying to make this thing continuous. We want it to be continuous at x equals 1. So we want to use this continuity test and ensure that it's continuous. We're going to set all 3 of these things equal to each other. Technically, we only have 2 pieces to set equal to each other. Sometimes, and you can write this off to the left-hand side, sometimes you'll have a piecewise function that looks like this. I'm going to just choose like f of x. Could look like this. It could have a function here, a function here. It could have 3 functions, one for when you have like x less than 1, one x is equal to 1, one for x is greater than 1. You could have 3 pieces and you need to set all 3 of them equal to each other. In this case, I only have 2 of them. One of them is combining them, right? So this left piece is also the same thing as the equal to piece. So this is taking the place of 2 of those pieces of the definition for our continuity test, which makes it a little bit easier for us. But sometimes you might see these 3 and you might see it on the test. For me, you might see it on the fix-ups, stuff like that. You might see it anywhere. So here we go. I'm just writing out the definition again. You always start, whenever you're talking about continuity, write out this test. It's another thing to memorize. Left is equal to right is equal to the height. Left, and if you don't like writing out the limits, you can go ahead and just write, whoa, got weird lag. You can say left is equal to right is equal to height. If you don't want to memorize that crazy definition, this is the main thing that you need to know. The left piece, hey, that's this piece right here, the 4x squared minus 3x plus 1. So I'm going to write out 4x squared minus 3x plus 1. That's the left piece. That needs to be set equal to the right piece. And that's going to be kx squared plus 7x minus 2. And that needs to be set equal to the actual height, the one where it has the equal to sign. So if you want to put in parentheses here, the equal to sign, where is the equal to sign? And I know that might be confusing by putting that equal to again, but the equal to sign is the same thing as the left piece. It is really silly to say this. If you want it in your notes, you can, but it's essentially rewriting the 4x squared minus 3x plus 1. We've already written it, so I can just kind of get rid of it. We've already talked about it. So I'm really just solving this equation when I plug x in, or I plug in 1 in for x. Again, I'm always plugging in the suspect point in the place of x, just like we did up here. We plugged in 2 in for x, 2 in for x, and we got 4. Now down here, we're going to plug 1 in for all of the x's. So I'm going to do that substitution with you guys. Plug 1 in for x. So we get 4 times 1 squared minus 3 times 1 plus 1 should be set equal to, there's nothing I can plug in for k. I'm going to solve for k. That's what it's asking for. What value of k will make it continuous? So I have k times 1 quantity squared plus 7 times 1 minus 2. All right. I feel like I've done too much talking. Someone else help me out. Someone else do math. Go for it, Fiona.
4 times 1 is 4 minus 3 plus 1 is 2.
Perfect.
K plus 7 minus 2 is k plus 5.
Perfect. Therefore,
K equals negative 3.
there it is. And box it. That's what the question was asking for. What value of k will make this thing continuous? Well, we used the continuity test. We set up our function. We plugged in our suspect point, and we got out k is equal to 3. We know the value of k that makes it continuous. The value of k that makes it continuous is negative 3. That's the hard version of using the continuity test, when you have to actually find a value that makes it work. Just checking it is a little bit easier, because typically the functions they give you aren't that hard. Okay. That's all I have for notes. Questions? All right, give me the fist of 5 for our objective today. How well can you determine types of discontinuities, the whole, removable, gap jump, stuff like that, along with being able to prove continuity or check the proof of continuity? I got 4, 5, 4, 4. Nice. All right, those are good numbers. We have 4 assignments on Khan Academy, I believe. 4, let me check right here. On Khan Academy. Yep, it's 4. We have classified discontinuities, continuity at a point, graphical, continuity at a point, algebraic, and continuity over an interval. You should be doing these types of things all for the homework, and that homework is due on Monday. I'll also point out that since today is Friday, I'm checking tonight that all of your notes with their summaries are uploaded to Google Slides. So make sure that notes 1-1 all the way through today's notes 1-4, all of them with summaries are on Google Slides.